All right, today we want to compare types of mixtures. So we're going to actually look at three types of mixtures today, and we're going to compare and contrast their features. So we're going to start with a solution. So let's talk about a definition. Now, the term solution we've actually talked about before because it's a homogeneous mixture. So earlier in the school year, we talked about homogeneous and heterogeneous. And we know that in this case, we're looking at a substance that looks the same throughout. So it's usually composed of two or more substances. So a great example of this would be salt water. So if you think about salt water, it looks the same throughout, just looks like clear, colorless. And it's composed of water and salt. Okay. Now, this is also uniformly dispersed. So today we're going to look at a particle diagram of a solution. And I already mentioned it looks the same throughout, so that's what I mean by a single phase. All right, now of the three mixtures we're going to talk about today, the solutions have the smallest particle size. Okay. And what I mean by this is it's 0.01 nanometers to an actual 1 nanometer size. So in other words, when you look at it, you can't see those individual particles. They're just too small to see with their naked eye. Okay, let's talk about separating a mixture. Okay, so primarily when we talk about separating mixtures, we're going to talk about filtration. So these cannot be separated by filtration. Again, the particles are too small. And it also cannot be separated by filtering or settling. Which means that if no matter how long I leave it set out, the particles, the salt and the water are not going to separate on their own. Now, if we're talking about salt water, one way that we could do this is by evaporation. So evaporation would mean this is going to take place at like room temperature. So slowly the water would evaporate and you would be left with those salt crystals. We could also boil the water to a gaseous state and be left with those salt crystals also. Okay, so this is what I've been talking about, the substances that make up solution. Okay, so you see fresh water. So that picture shows you just water molecules. And then the other that you see here is salt water. So when we talk about a solution has actually two components. Okay. Okay. The water molecules, if you look at them, they're present in the larger amount. And the water is actually doing the dissolving. And we refer to that substance as being the solvent. Okay. And so in this example, water is the solvent, but it doesn't have to be water. Okay. Right. Now, the other particles that we see here, the sodium and chloride ion, come from the salt. And this is present in the smaller amount. and it is the substance that is being dissolved. And we refer to this as the solute. Okay, so solutions, most time when we think about solutions, we think about a solution that's in a liquid phase. So typically you've taken a solid and you've dissolved it in a liquid. But it's important to note that solutions can have many states of matter. Okay, so if we're looking at this figure from your textbook, you can see it's possible for the solute to be a solid, a liquid, or a gas, and the solvent also to be a solid, a liquid, or a gas. So they can occur in any state of matter. Okay, so that's our first type of mixture is our solution. Okay. All right, let's look at our next type of mixture. We're going to talk about the colloid. All right, so the official definition of this is that it has particles that are intermediate in size between those of a solution and those of a suspension. So we consider this to have kind of a medium-sized particle. So let's talk about what we mean here. Right. So these have particles, the smallest size would be 1 nanometer, but these can go all the way up to 1,000 nanometers. All right, now typically, again, these particles are so small that we don't see them with our naked eye. So let's talk about how we separate out these particles. Okay. These can also not be separated by filtration. These can also not be separated by standing, so another by settling. But the one thing that these colloids have that we don't see with solutions or suspensions is what we call the Tyndall effect. And that's what we see in the image here on our left. And so what we see with the Tyndall effect is that these have particles that are just the right size that they can, so basically what they've done is they've taken a flashlight here and they've shined it through the liquids that are in each of these jars. And with a colloid, it has the ability to scatter the light. So that's why we're able to see that light beam. Solutions just have particles that are so small that you cannot scatter the light with them. And solutions are suspensions, which is the other mixture we're going to talk about. These have particles that are so large that it's not transparent like it is here with a colloid. Okay, so really we use the Tyndall effect to be able to separate a solution from a colloid. Okay, so let's talk about examples of a colloid that you might be familiar with. So, in the summertime in St. Louis, when it's really warm, we get this hazy brown look to it. So, we call this photochemical smog. All right. And then we can also look in the figure of your book and see the types of colloids. Now, you can see that colloids have classes, but you're not going to be responsible for the classes. But we should know examples. So, paint and mud would be an example of a colloid. And you can see the word here, disperse. So, we're going to talk about the phases of a colloid here in a second. Gelatin is an example of a colloid. Milk, mayonnaise, shaving cream, whipped cream, smoke. We talked about photochemical smog, but fog would be the same. Cheese and butter, so knows the word emulsion, so that's also another vocab word for the chapter. Okay, so let's talk about, so with solutions, we have the word solvent and solute. With colloids, we have the words dispersed phase, so these are the actual colloidal particles. And we have the dispersing medium. So what those colloid particles are dispersed in. So typically where you think of water here as our dispersing medium. Okay. So colloids typically be difficult to identify when you're looking at it with your visual eye, again, because particles you cannot see. So it's heterogeneous on a microscopic level, so what you can't see with your naked eye. So really the only way to distinguish a solution from a colloid is to use that Tyndall effect. All right, and then let's look at our next type of mixture. So our next type of mixture is a suspension. Okay. And so this has particles that are going to settle out. Unless this mixture is constantly stirred. Now, of the three types of mixtures we talked about, the suspension has the largest particle size. So when we say largest, we're talking that it has to be at least 1,000 nanometers or larger. Now, because the particles in a suspension are so large, we can actually use filtration to separate the components. And again, because the particles are so large, these particles are going to settle out. Once you stop stirring, those particles are so large, they're going to settle to the bottom. All right, and we've talked about the fact that this, because of the particle size, would also scatter light, but it's not transparent like we see with a colloid. Okay. All right, so my picture here is basically I have muddy water, and so it's been stirred up or shaken up and then set down, and you can see that those clay particles have settled to the bottom, and so you see that water layer at the top. Now, suspensions don't have components like we said with solutions or with colloids. All right, so let's talk about some examples. So think of anything that has to be shaken or stirred, typically as a suspension. So those cough syrups that you have to shake before you dispense it out of the bottle. Here you can see my layers. So we have an oil spill, in water. So you can clearly see the oil and the water layers here. And so we're going to spend some time in this chapter talking about why one substance will mix in water and why one substance will not. So we're going to loop it back around to this oil spill in water once again when we talk about how the dissolving process works. Okay, and then there's one other types of vocab words that we want to talk about in this section, and that is the term electrolyte and non-electrolyte. And then we're going to look at my picture here. So let's define it first. So here we have a substance. Now here we're typically talking about a solution. So we're taking something and we're going to dissolve it in water. So the characteristic of this solution is that it's going to conduct electric current. Okay, so I feel like we've spent some time already looking at this during first semester. So we know that in order for us to be able to conduct electric current, you have to have some kind of charged particle that can move. So the best example of this is going to be an ionic compound. So think about what we know about ionic compounds. Okay? We take them and we look at them and we know they're made of ions. And when we put those ions in water, it allows those ions to be mobile so they can dance. Remember, we talked about that in chapter 8. And so because you have those ions moving, they are conductors. So think about your salt water. Okay. So if you've looked at like a hair dryer, for example, it has a huge warning label on it, not to drop it in water. So the water that comes out of your tap is not pure. It has substances dissolved in it that makes it a conductor. So you can get electrocuted when you drop that hair dryer in your bathtub. All right, a non-electrolyte, again, here we have a substance, and we're going to dissolve it in water. And that's going to give us a solution. But in this case, it does not conduct electricity. So again, we're taking a substance that doesn't have any charged particles. So a molecular compound doesn't have charged particles, and we're dissolving in water. All right, so let's go back in time a little bit. Mineral oil would be an example of this. It's a molecule. It has all non-metals in it. It has carbon and hydrogen. It's actually a hydrocarbon. So because there's no charged particles, it means it's not a conductor. All right, so let's look at my diagram here. Let me see if I can shrink it down a little bit. Maybe not. All right, so the first one here on my left, sucrose, if you're looking at the model picture, it tells you it's a molecule. So molecules don't break apart into any kind of ions that can move. And so you can clearly see the light bulb doesn't light up, so it's a non-electrolyte. All right. We're going to see in this chapter that anything that's an acid or a base is electrolyte. Now here we don't show any bases, we just show acids. So here in my second picture, I have acetic acid, and you can see that you have ions. You have a hydronium ion and you have an acetate ion, and those charged particles are what makes it a conductor. Now, if you also look at it, the light bulb is not as bright as it is with our last two pictures. So that's a clue for another day. Our third photo here is our salt that we already talked about. Again, we see our ions. We see a sodium ion and a chloride ion. So again, charged particles that are dancing makes it an electrolyte. And then the last one is also an acid. So this is hydrochloric acid. So again, it gives us a hydronium ion and a chloride ion. And the bulb is pretty bright here. So again, we'll come back and talk about that for another day. All right, so this is our discussion about types of mixtures. There are lots of vocab in this section that you're responsible for knowing. I highly recommend making flashcards and practicing the vocab. In chemistry class, though, it's really an application of vocab. So as much as you can practice the application of identifying a solution, a colloid, and a suspension, the better off you are.